Hey, today we're going to be talking about the energy for contraction, mostly ATP, how we get our muscles to move and for how long of a duration, which is really important if we want to understand how our body moves. So starting off, we have cytosolic ATP, and this is kind of free floating around in the cytosol in your cell. And so there's not a ton available, but it is free floating. It's there. It's anaerobic. You don't need oxygen to metabolize it, so to speak, or you don't need oxygen to use it. It's just immediately available, and so it's going to be used for the smaller contractions. So for instance, in your eyes don't contract for a long amount of time. You just move them and then they're set there, and then you'll use another muscle in your eye or surrounding your eye to move again. So it's not going to be contracting for a long period of time. It's not like you lift weights or go running with your eyes, right? You move, you're done, right? So not a ton of time. Downside, I guess, is you can't sustain it for a long time, so you might have fatigue with your eyes if you move them for too long or stare at a screen. A second source of ATP would be creatine phosphate, and what creatine phosphate is going to do is it's going to transfer its phosphate group to ADP very quickly through an enzyme called creatine kinase that's found mostly on your M line in your sarcomere. So in the muscle, you need ATP to have your contractions, right? To release and have that cocked and uncocked position. And so instead of trying to find new ATP, what creatine phosphate will do is take used up ATP, it'll take ADP, transfer its phosphate group on there, regenerating ATP, so you can go through another contraction, right? And that is an anaerobic process. You don't use oxygen, and you can do it several times. It's not like you're limited as much as cytosolic ATP, where you just one and done, you use it up and it's over. You're continually replenishing ATP for about 10 seconds. You can extend that contraction to 10 seconds. With the eyes, it was 5. With this, it's 10 seconds. So creatine's super widely studied, and we see it a lot within a weightlifting culture. That's anaerobic exercise. You're only lifting weights for about 10 seconds anyways. And so the downside would be if you use it for running and it's not going to benefit you a ton. But in weightlifting, there are benefits. They're just small and selective towards the exercise that you're doing because it's a short duration. So if you want to lift heavier weights, you can use creatine and extend that contraction time to about 10 seconds. Glycolysis is essentially the breakdown of glucose in your body from what you eat. And also it can break down glycogen, which is a form of energy. It's very similar to glucose. It's stored energy within your body, within your muscles and other places too. It's anaerobic. You don't need oxygen, just like the other two. It's our main source of ATP during anaerobic activity. This is intense activity for about a minute. So with weightlifting, it's probably 10 seconds. With intense activity up to 1 minute, that would probably be like your high intensity interval training, where it's a lot of energy used up within a minute or two, and then you rest again. But it's anaerobic. Aerobic respiration, which we'll get to, isn't going to do a ton in that scenario. But this will help you extend that contraction time, or those contraction times, for about a minute until you fatigue. Finally, we have aerobic oxidative aerobic or oxidative respiration. This will be a constant supply of ATP. So in previous sources like cytosolic ATP, creatine phosphate, or glycolysis, you start at a minimum of about 1 to 5 seconds, and we can extend it all the way up to a minute. But obviously we move a lot more than just 1 minute at a time. And so we're going to need a lot more ATP in order for us to get through the day and do pretty basic functions. So what this is going to do is it's going to use mitochondria to generate this ATP. It's aerobic, meaning it uses oxygen to produce the ATP. It's so far the only one that has oxygen use in it. The benefit to this is that it can extend your contraction time up to, or for hours. And that's why it's used in walking, jogging, any type of aerobic activity, because you're sustaining muscular activity for more than just a minute at a time. When you're running, it's probably going to be about 30 minutes or so that you're exercising, and so you're going to be breathing hard and taking in oxygen so that we can generate more ATP. The only downside to this is it's a lot slower, obviously. It's not going to be immediately available if you deplete it, but it will supply a greater amount of ATP so that you can continue those exercises or that movement of muscle. Good for moderate activity like walking or jogging. And then finally, in glycolysis, we broke down glucose. But with oxidative respiration, we can break down glucose, but it prefers fatty acids. It's just more bang for its buck. And so it's going to prioritize the fatty acids in its breakdown to produce more ATP for your movement. And so these are the sources of ATP, or the energy for contractions, and what powers essentially how we move and how we can even function. So yeah, there you have it.